these as we do these. Okay, so 2 to the second times 2 to the third is equal to what? 2 to the fifth. And what is the property for multiplying exponents? Add. Everybody good with that? I mean, these are basic, that's algebra 1, but we should know that when we multiply exponents, we add exponents. Okay? And what happens here? 3 to the 4th, 3 to the 5th raised to the 4th power. Is this a true statement? Is it 3 to the 4th, 5 to the 4th?
Yeah.
Okay, so you're multiplying everything within the fraction. So 3 to the 4th, 5 to the 4th. We're good with that. Okay. How about in number 3?
No.
Okay. What should it be?
3 to the 4th times.
Okay. So you need to make sure. Pardon me? It's kind of like the distributive property, but you need to make sure that you, it's 3 times this quantity. You'll often see it like this, like 2x raised to the 2nd power, okay? Well, you need to know that the 2 is being squared, as is the x. Well, that's what we're doing. For number 3, if I'm writing this, I mean, one way of noting this, I could have said 3 times 11 and done that, but if I'm just doing the exponents, I'm taking, it's this idea. I mean, I couldn't simplify here, could I? But it would be that quantity squared. Stephen?
Would the property be distributive property?
It's raising up to a power, because this is really 3 to the 1st. So it's called raising to a property, raising to a power, raising to a power.
Is that what number 2 is as well?
Yeah, it really is, because this is really 3 to the 1st and 5 to the 1st. It's raising to a power. And you just need to remember that when you're multiplying exponents, you're adding, whereas this is actually a multiplication process. And here it is again, 7 to the 2nd raised to the 3rd power is going to be what? 7 to the 6th, because we're raising it to a power. We're taking an exponent and raising it. Okay, how about 6 to the 7th over 6 to the 4th is 6 to the 3rd. What is that? Everybody?
Why is 4 7?
It's true.
Sorry.
It's like 7 minus 4.
Because we are doing, so you know when we multiply exponents, we add. When we, for number 5, when we divide.
No, I understand number 5, number 4. Isn't that multiplying exponents on number 4?
No, but you're finding the exponent of an exponent.
Yeah.
You have to multiply 7 squared times 7 squared.
You're taking 7 squared times 7 squared times 7 squared.
Okay. Oh,
So I'm multiplying my exponents, I'm multiplying that, and that means the rule is that we add them. So 7 would be 7 to the 6th. Okay? So that's what that is. This one, when we divide exponents, we do what? Okay, when we divide exponents, we subtract. And this one was raising to a power. So if you're not sure, the easiest thing to do here is just say 3 to the 2nd times 3 to the 2nd times 3 to the 2nd times 3 to the 2nd. Is that the same? Is that the equivalent?
What is that rule?
This one is it's raising to a power. It's the
That's
same
still
one.
raising to a power.
Yeah, you're raising this to that power. Okay, it's raising to a power. And I'll show you. It's a nice little thing in your textbook. I wasn't sure how much you would remember. Okay, so let me ask you this. It sounds like most of you are actually pretty good with your exponents. How about,
I don't understand the directions to the next one.
okay, hold on, I'm not there yet. Okay, so what I'd like you to tell me is, what is 3 to the 1? 3 to the 0?
One.
1, why?
Because anything to the zero is one.
Why?
I have no idea.
Anybody? Matt? Okay.
Oh, wait, we did this before, because if it's,
Haley, do you have an idea?
Well, can I go to the bathroom?
Yes.
Because
Okay.
it's, isn't it something to do with like, it's not like you're actually multiplying it by zero, like it's not 3 times.
That's right.
Yes.
Okay, so I'm gonna show you a way that I explain it, and I hope it makes sense to you. Now I can find it, 'cause to me, it makes sense. So would you agree? Would you agree so far that if I had 2 to the 3rd equals 8, 2 to the 2nd equals 4, 2 to the 1st equals 2. Is there a pattern that you see here? How are my numbers, each time I decrease by 1, what happens to my answer? It's divide by 2, okay? Or it's decreasing in half. So what would it make sense for 2 to the 0 to be?
One. Half.
Right there. Okay, so if it's decreasing in my exponents, I want you to know, I think that whoever came up with the idea of exponents was brilliant, because we're going to talk about where that negative exponents fits into this. So my numbers are decreasing by 1. My values are decreasing by half. So what will 2 to the negative 1 have to be?
1/2.
And 2 to the negative 2 is going to be
Quarter.
1/4. Or could I not write this as 1 over 2 squared?
Good.
Okay? So is this a true statement?
Yeah.
Okay? So just remember, if you get stuck about those negative exponents, and this is where I think they're brilliant, elegant, okay? Well, think about this. I now have a way to show very small numbers. So I know if I have a negative exponent, my negative exponent means I'm talking about what? Fractions. And without changing, really, only other than adding a negative sign. And I think that that's very cool. Yes. Okay, so does anybody have any questions about why? That's one example. I have another example to prove to you that any number to the 0 power is equal to 1. How about if I had 2 to the 3rd, I don't know, every marker I'm picking at. If I had 2 to the 3rd divided by 2 to the 3rd, what's the rule for division of exponents? Subtraction. So is this true?
Yeah.
Okay? And is 2 to the 3rd equal 8? 2 to the 3rd is equal to 8, and is 8 over 8 equal to 1? So does 2 to the 0 equal 1?
Yeah.
Okay, so is everybody comfortable with that an exponent to the 0 power will always be 1? Okay, good. All right, so let's go down to the bottom of the page. And let's see if you, whoops, I'm on 7, let's see, right from the wrong side. How would you do number 25? Do you remember how to do these? These are in scientific notation.
Ooh,
You have to move
Simplify.
the zero.
Okay? Anybody?
32.
Okay, so I'm going to multiply. Now
It's all
remember,
multiplication, so you can do 3.2 times 2.4.
Good.
Do 10 to the fifth times 10 to the negative third.
okay, that's perfect. So that's what you want to do on these types of problems.
Do you have to use the FOIL or do you just do 2.2
No.
times?
It's all multiplication.
This is 3 times 2, and I think we did this the other day. 2
Okay.
times 3
Yeah,
times
okay.
4 times 5.
Yeah.
I can multiply any order that I want.
I remember.
Okay, so in my case, I'm gonna say 3.2 times 2.4, click, 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 what is it?
7.68.
7.68 times 10, now I'm multiplying 10 to the 5th times 10 to the negative 3, and what's the rule for multiplying exponents?
Add them.
How do I multiply exponents? Add them. So I'm going to have 7.68 times 10 to the second. Okay, everybody good with that? Is that pretty straightforward? Okay.
So we leave it like that?
Yes, you can leave it that way. Supposing, and I'm messing with this problem right now, supposing we had multiplied and your answer was 76.8 times 10 to the second. Remember, this is saying I'm going to multiply this number by 10 to the second, which is 100, so my final answer really is going to be there. This 7.68 is in scientific notation because we agree, and it's just an agreement amongst mathematicians and scientists that it's the decimal is after the first digit, not including the first whole number greater than 0. Okay, so it wouldn't be 0. It would be a 1 there. So in this particular case, I'm writing 7.68. Is this in scientific notation? No. So now think about it. I'm moving my decimal 1 digit further away from where it's going to be. So this is now going to be 10 to the third. It's now going to have to move 3 places over. Okay? Anybody have any questions on these? I'm hoping that this is pretty much review. So if we can charge through this week, Monday when we come back, I'll probably do a little bit of a review with you.
One more day this week.
I know.
What?
Charge through this
We're
week?
having I forgot that I wasn't gonna teach tomorrow. Okay. So yes, tomorrow was our chapter 5 test of the quadratics.
Is
So
that just gonna be on the conic section?
Yeah, this
just
is,
the conic section, not this.
Okay.
Not of this. You may use your notes only on the circle, hyperbola, Kayla, listen to me. Only on the circle, hyperbola, and ellipses, not on parabola. So you should know and go back and look at the test that I gave you a while ago on finding, solving for x with 0 products.
wait,
Okay, the
so-
0 product rule. What does the 0 product rule mean?
M times n equals 0, then n or n.
Okay, so you're going, and so
Wait, so our test on we can use our notes on hyperbolas and what else?
circles and the ellipses.
So should we make notes, Carson? Because like my notes are in my little flip up of my travel.
Okay, well, I will see, yes. You know what, you may use your hyperbola notes that is. I'm not gonna ask you for this.
Yeah.
So what notes can we use?
Circles, all the conics except parabolas.
We can't use notes.
No, we can.
All except parabolas.